Hello everyone. Today we are launching the preview version of Phanthy, an AI platform that integrates vertical world models. We hope to use this opportunity to show you what we believe is the direction of future AI development. Currently, large models have entered every aspect of life, but there are still many fields, especially in professional, data-precise, and practical problems with business or mechanism constraints, where the performance of large models often falls short of our expectations for AGI. Let's take a look at an example. In aviation engineering, high-precision wind tunnel data serves as the cornerstone of design. Wind tunnel simulation is one of the crucial benchmarking methods in the early stages of design, used to quickly verify aerodynamic performance and design specifications. At the same time, inaccurate simulation results can lead to significant risks and costs during the trial production phase. Therefore, in the daily work of aviation engineers, they need to repeatedly go through the cycle of design, simulation, and optimization to meet the technical requirements of aircraft. Let's see what happens when aviation engineers provide mainstream AI with a three-dimensional model file of an aircraft for wind tunnel simulation analysis. The hope is that it can provide the wind tunnel simulation analysis engineers need, offering reliable data for aerodynamic design. This answer seems reasonable, but upon careful review, it is found that it merely stays at basic analysis and simple geometric calculations, lacking the precise analysis necessary for high-fidelity simulation. This clearly fails to meet the professional requirements of practical engineering. When engineers use the same aircraft model to test another mainstream AI, it clearly reflects the current capability boundaries, unable to perform wind tunnel simulation. Its feedback focuses on theoretical formula calculations, accompanied by visually limited materials and tutorials with limited relevance. This fails to meet our core requirements, and some models even do not support this professional file format. Let me give another example. On our blue planet, the ocean is a world where sound is far more important than light. Light attenuates rapidly in water, while sound waves can travel over long distances, making sonar a key tool for humans to explore the deep sea and carry out reliable operations. Sonar is widely used in scientific research, fisheries, rescue, and other fields. However, traditional sonar analysis relies on expert experience, which has perceptual limitations. Experts have to judge whether a target exists, where it is located, and how fast it is moving amidst noise interference and complex echoes every day. They urgently hope to analyze sound and identify targets through artificial intelligence, making detection efficient and accurate. If a sonar expert uses the current mainstream large models to analyze a sonar image, what kind of response will he get? Some models treat the file as an ordinary grayscale image, without providing the actual location. Some models, after 5 minutes of contemplation, treat it as a multiplication math problem and give their answer. Some models stop at the file level, telling you that this is a TIFO file and it requires data such as TDOA, completely unaware that the image itself contains sonar information. The same awkwardness also appears in health management. If a doctor or health manager gives an AI model a physical examination report and asks it to predict the diabetes risk in the next 3 years, it can indeed explain blood sugar, weight, and other factors convincingly, appearing very professional. However, when it comes to the professional level of risk prediction, some say they cannot provide a medical diagnosis, while others throw out a vague result without a verifiable execution range, and cannot explain the basis and error range. This is not a criticism of anyone, but a fact that many complex professional issues are far from being adequately addressed by language modeling and understanding alone. Without a professional model specifically built for the problem itself, AI remains stuck in recognition rather than resolution, and sometimes even recognition is impossible. Why are many large language models ineffective in professional scenarios? The fundamental reason lies in the fact that in the real world, a vast array of professional issues, whether it's fluid simulation, signal analysis, or physiological prediction, are inherently difficult to depict and solve with a single language model. They require the construction of vertical world models belonging to the respective fields based on domain mechanisms, professional rules, and high-quality data. Over the past decade, we have continuously accumulated large-scale, traceable, and quality-controllable professional data in fields such as finance, aerospace, manufacturing, and healthcare. Now we integrate these data with deep mechanism models and industry rules to meticulously construct professional world models in various vertical domains, making them the cornerstone of Phanthy. Each vertical model is tailored to the unique characteristics of its domain, enabling us to truly understand and address professional challenges. This allows us to build Phanthy, a truly professional and scientific platform for vertical world models that support complex decision-making. This platform will gather a wealth of professional wisdom. We can see that on Phanthy's World Model Square, we have uploaded a batch of vertical world models for everyone to see, including wind tunnel tests, sonar monitoring, diabetes risk prediction, and more. In addition, we will continue to update more vertical world models. More importantly, we are open to the ecosystem and welcome any individual or institution to share their professional models here. Join the expert network through a unified interface and work collaboratively with existing world models. Next, I will demonstrate with 3 real-world tasks from different vertical domains. The first case study demonstrates how automotive design engineers can significantly enhance their work efficiency through Phanthy. We can see that the engineer handed over the 3D design file to Phanthy. After analysis, Phanthy first determined that it was necessary to consult the wind tunnel world model from the model library, which we will refer to as the wind tunnel expert. We can observe some of the processes thought by the wind tunnel expert. Very quickly, the expert completed its calculation work, provided the conclusion to Phanthy, and simultaneously presented it to our users. In terms of the results, besides the final drag coefficient, we can also see many detailed results, including renderings of the front, side, and top views, as well as an interactive 3D model. Regarding the sonar analysis task mentioned earlier, what would be the result if the same sonar image were given to Phanthy? We can see that Phanthy first decided to consult the expert on the sonar detection world model, and simultaneously, the sonar expert began to perform very intensive calculations. Very quickly, it obtained the results. We can see from the result graph that the location of the object and its trajectory have been determined for each receiving point. For the last case, let's return to the field closest to our daily lives, health management. Still with the health manager we mentioned earlier, he uploaded a user's physical examination report. We can see that Phanthy first decides to consult using the diabetes predict world model of health management. Then it quickly analyzes the results and provides some suggestions. Besides the normal suggestions, it also provides the decision-making basis based on a vast amount of real user data. These bases can make me more confident in trusting such a result. The 3 cases we just saw are merely a corner of the world model behind Phanthy. The key to achieving general artificial intelligence lies in recognizing that one model cannot solve all problems, and shifting towards organically organizing numerous vertical world models. Just like building a pantheon, each vertical model represents an industry expert. Therefore, we sincerely invite experts and developers from various fields to integrate your vertical world models into Pantheon. Let's jointly build a diverse model ecosystem. Every professional intervention is a big step towards AGI, and this is the general artificial intelligence that Phanthy leads to the real world.